Hi, this is the fourth lecture in unit number 1 of the trigonometry, portion of this class. So it's lesson 4 for unit 1 of trig. And this lesson goes with the notes page that is entitled Using the Definitions of the Trig Functions. There are actually 2 assignments that follow this set of notes. They're labeled homework 4 and homework 5. And so you'll be working on those in the next couple of days. The first heading in your notes is reciprocal trig functions, and we actually have discussed this already. This is just really a recap just to remind you of things. If you think about it, the main 3 trig functions that we know are sine, which is abbreviated SIN, sine of theta, and then we have cosine, and then we have tangent. Okay. We have discussed in the previous notes how sine, if you think about a reference triangle, is y over r, cosine is x over r, and tangent doesn't involve the hypotenuse, it is y over x. Okay, so you can have a picture that goes with this to help out with the labeling, so you remember that this is x, this is y, this is r, for example. Okay? And the reciprocal trig functions are where you flip each of these over. Reciprocal means to flip a fraction over. So r over y, r over x, and x over y would be the 3 reciprocals. And each of these is given a name. The reciprocal of sine is cosecant. The reciprocal of cosine is secant. The reciprocal of tangent is cotangent. Okay, so that's actually from the most recent set of notes before this one, and you've used it in homework a little bit, but just wanted to recap that one more time. Okay, the reciprocal trig functions are the ones that are the reciprocals of sine, cosine, and tangent. Okay, you just flip them over. The next heading says using a calculator to evaluate trig functions. So if your calculator isn't in front of you, pause this and go get it. Sometimes we will want to use a calculator to evaluate a trig function. Our calculator has all of the different values of sine, cosine, and tangent stored in its memory, okay, because these are just ratios of triangles' sides, so that the calculator can know those and figure them out, or figure them out. So if you were to type into your calculator sine of 30 degrees, your calculator is going to think about, so to speak, a 30-degree angle in a right triangle, which means this would be 60 degrees. It's going to take a specific 30-degree, 30, 60, 90 triangle and be able to figure out the ratio of the opposite side to the hypotenuse in any triangle like that, okay? And what it should give you is 1/2. If your calculator, instead of giving you 1/2 or 0.5, is giving you an answer of negative 0.988, etc., that means that you need to adjust the calculator's mode. Okay, so when we use a calculator and we're dealing in degrees, we need to first go to the button that is called mode, and we need to make sure that that mode, rather than being set into radians, is set into degrees. Okay, so the thing that should be blackened in or highlighted or whatever is the degree mode. Okay? Because this is sine of 30 degrees. Okay, so sine of 30 degrees should give you 1/2 or 0.5, whichever formation you prefer. Okay? If you want to do cosine, let's say cosine of 60 degrees. Okay? You would type that in, and you just type in COS is a button. It's 2 rows above the numbers. You see those, sine, cosine, tangent, right on your keyboard. And you type in cosine of 60, and look at what answer it gives you. Isn't that interesting? Can you think of why that would be? Look at that triangle that we have drawn there. Yeah, cosine of 60, here's 60. Cosine is adjacent over hypotenuse, which was the same as opposite over hypotenuse for the 30-degree angle. Now, not everything turns out to be 1/2, so let's do a different example. Let's say we do tangent of 45 degrees. Okay, use the tangent key. Tangent of 45 turns out to be 1. That's correct, okay? Now, in case you're really lost at this moment, the buttons I'm talking about on your calculator, I'm drawing a calculator here. I know that's really high tech. Okay, you have the buttons down here that have, say, 7, 8, and 9 on them. And then a little bit above that, not right above, but a little bit above that, there's a button for sine, a button for cosine, and a button for tangent. These three things are what I would have used here, here, and here. And then you just type in the number after that. Okay? Now, what's a little bit tricky is when you need to use your calculator to evaluate reciprocal trig functions, because there isn't a button that says, for example, cosecant. Let's say you wanted the cosecant of 30 degrees. Well, I can think of two ways to do that. One way to do it would be to say, well, I already know that the sine of 30 is 1 over 2, right? We found that out up above, right here, okay? So if sine of 30 is 1 over 2, the reciprocal of sine is cosecant. So what's the cosecant of 30 going to be? Better be the reciprocal of this, right? Switch this around. These two guys are reciprocals of each other, okay? So that's basically what you would do. If you hadn't already figured out what the sine of 30 was, like let's say you wanted to find the cosecant of 40 degrees, I would find the sine of 40, and then I would take its reciprocal. So that is equivalent to, in one step, that's equivalent to doing this. This means the reciprocal of the sine of 40. You take the sine of 40 and then you flip it to be on the bottom instead of on the top. Okay, well that you can put right into your calculator. You can type 1 division sine, sine, button, 40, and it equals. Okay, I'm going to go ahead and do that because I don't actually know what that is off the top of my head. I got 1.556. Okay, it's a good idea when you're giving calculator answers to round to 3 decimal places. Okay, that gives us enough accuracy for anything we're going to do. Okay, all right, in our next section, I have a little graph set up there for signs of trig functions. Okay, so if you were to think about a reference triangle over here in quadrant 1, this length, let's start with this. If I think about the point x, y up there, x here is positive because I'm going to the right. Y is positive because I'm going up. And we've discussed, I hope in class at this point, that this side r is always positive. Okay? So no matter what I do here with taking x over y or y over r or any of the trig relationships, I'm going to have a positive divided by a positive. And what is that? A positive. So all the trig functions are positive in quadrant 1. Okay, now let's think about in quadrant 2. I'm going to take this triangle out of here because I have a feeling it's going to get pretty messy by the time we're done. I just wanted you to be able to look at that. And now let's look at this triangle instead over here in quadrant 2. Here's our point on the terminal side of the angle. It's x comma y. But in this case, since x is going to the left on the coordinate plane, x is actually negative. Y is going up, so that would be a positive amount. R is always positive. So if you think about your trig definitions, remember the other day where we had that slip of paper with y over r, x over r, all that, okay? Anything that involves an x now is going to be negative. So which trig functions involve an x? Well, 4 of them do. Everything except for sine and cosecant. So in quadrant 2, sine and its reciprocal cosecant are positive, and all the other ones are going to be negative, okay, in quadrant 2. I'm going to take that picture out because, like I said, I think it's going to be a little bit cluttered. And let's come down here to quadrant 3. Here's our reference triangle for quadrant 3. Now in quadrant 3, I'd be going to the left for x, so x would be negative. I'd be going down for y, so y would be negative, and r is always positive. So if you look at your different trig relationships, how could I end up with a positive quantity? For sine, y over r would be negative. Cosine, x over r would be negative. Oh, the tangent. tangent is y over x, and a negative divided by a negative would be positive. So in quadrant 3, tangent and its reciprocal cotangent are positive, but everything else is going to be negative. Every other trig ratio in quadrant 3 is going to be negative. I should say in quadrant 3. Okay. Okay, good. Last one. Here we are in quadrant 4. In quadrant 4, I'm going to the right for x, so x would be positive. I'm going down for y, so y is going to be a negative number. No matter what that point is, I'd have a positive and then a negative. And r is going to be a positive amount because it's a distance. Okay? If you look back at your definitions, your trig definitions, how could you end up with something positive? The only way would be dividing those guys, the two positive quantities, because if you involve y, you're going to get a negative amount. So in quadrant 4, cosine and its reciprocal, secant, are positive. And this is quadrant 4. Okay. Now, if we were to just focus on those words that we've come up with, not so much the picture. I mean, certainly the picture is how we got the words, but just focusing on the words. I'm going to give you a mnemonic device, which is a memory aid, okay? This memory aid's name or title would be what is positive? What is positive? What trig functions are positive could be the name of it. Notice over here, sine is positive. Here, tangent is positive. Here, cosine is positive. And here, all things are positive. Now, I know I did ignore the reciprocals, right? I didn't mention cosecant or cotangent or secant, right? But I hope you know which things are reciprocals, okay, at this point. I just focused on the SOHCAHTOA ones, right? Sine, cosine, and tangent. Now, if you look at those 4 black letters, this is the mnemonic device. All star trig class. You're an all-star trig class, you guys. And these letters should help you remember which trig functions are positive in each of the quadrants. For example, this S should remind you that sine is positive in this region, in quadrant 2. And because sine is positive, its reciprocal has to be positive also, which is cosecant. Okay? All right. This next part is going to come up more when we're dealing with the graphing unit in upcoming weeks. But I'm just going to introduce this to you for now, okay? Sine and cosine. If I were to punch in sine of something on my calculator or cosine of something on my calculator, sometimes it's a little bit mystical, like how your calculator comes up with answers, and it's important to know when things are going wrong, okay? So if you were to type in sine of something and your calculator gave you the answer 2.6, I would know immediately that something was wrong, because it's a fact that sine and cosine should give you answers between -1 and 1. There's no way that your answer could be 2.6, for example. Okay, this information here between -1 and 1 is what is called the range of the sine function or the range of the cosine function. It's the range of values that you can get as answers. Okay? Let's do the next pair. Tangent of something and cotangent of something. If you're doing problems like that on your calculator or in any other way, your answers can be anything. So answers can be any real number. Now, the sophisticated way for writing these, I haven't really brought up, but I probably should. Up above, we would say that the range is in between -1 and 1. That's what's called an interval right here, this thing I've written. That notation means between -1 and 1. When an answer can be anything at all, we would say it can go from negative infinity to positive infinity. It can go as small as you want up to as big as you want. And so that's interval notation for this. These words in black mean the same thing as this and vice versa. Okay? The last pair of functions we have are secant and cosecant. Now remember that secant and cosecant are reciprocals of sine and cosine. So sine and cosine have answers in between -1 and 1. Secant and cosecant are sort of the opposite of that. Answers can be more than 1 or less than -1, or they can equal 1 and -1. Okay, so that's very wordy, and so here's where interval notation is kind of nice. The interval notation for this would say answers could be as small as you want until you get to -1, and it includes -1. So you have a square bracket here that show including, or starting at +1, bigger, bigger, bigger than that. If you were graphing on a number line, this same information would look like this. Answers could be less than -1, including -1, or they could start at 1 and be bigger than that. Okay, if we did a number line graph for sine and cosine's range, we would have the part in between -1 and 1. Okay, so if we were to think about that on this number line, here's where the sine and cosine answers are. And the red part is where the secant and cosecant answers are. Okay, so they're opposites of each other. Okay, whereas tangent and cotangent would be the entire number line. Everything would be shaded in for those. Okay, the last topic are what are called the Pythagorean identities. Okay, Pythagorean identities come from the Pythagorean theorem. And so in the Pythagorean theorem, you have a squared plus b squared equals c squared, right? That's the Pythagorean theorem. So the Pythagorean identities look a lot like that in format. I'm going to explain this more as we get to talking about the unit circle, but for now I just want to introduce them. The first Pythagorean identity is sine squared. Remember we talked the other day about how that little 2 really means the same thing as if you wrote it like this. If you prefer to write it with the parentheses, go ahead, but you really are going to see it more the way that I wrote it up above. So that means sine squared plus cosine squared equals 1 squared. 1 squared is 1. Okay? That is a fact. If I had a specific angle, like 42 degrees, the sine of 42 degrees, whatever that is, if you square it and add it to what the cosine of 42 degrees is squared, the answer to that will turn out to be 1. If you do not believe me, you can try it on your calculator. And you can put any numbers here that you want as long as they match. See how these are both thetas, so it has to be the same number in both of those slots. Okay? This is a useful thing, believe it or not. It maybe doesn't seem useful right now, but it is. It's a formula, and so like any formula, if one thing is known and the other thing isn't known, then you can figure out the missing part. Okay? So this is the first of 3 Pythagorean identities. To get the other 2, I would actually recommend that you really, really, really memorize this first one. And then to get the other 2, you can kind of work from this one and figure out the other 2. So here's the first one. Say you divide everything by sine squared. Okay. Sine squared over sine squared, something divided by itself is 1. Cosine over sine is actually another way of saying cotangent. I'm trying to think right now if you knew that before. Maybe you don't. So that step we might need to talk about in class. Okay? I forget if you know that yet or not. And the reciprocal of sine, I know that you know. That was in the last lesson and at the start of this one. And that's cosecant squared. Okay? So this statement right here, I put a 2 next to. Okay, that's the second of 3 Pythagorean identities. Here's the first one. Okay, here's the second one that we just put this blue box around. Okay, the third one you also derive from the first one. Okay, I'm going to write it down again. That was sine squared plus cosine squared equals 1. Now this time, instead of dividing through by sine squared, suppose you divide everything by cosine squared. Okay, so this first fraction, this is the thing all of a sudden I'm not sure, maybe you don't know this yet, but sine over cosine is equal to tangent. So that's tangent squared, the square just follows along. Something divided by itself is 1. And this part, you'd think, well, the reciprocal of cosine, that's what that says. The reciprocal of cosine is secant, and then this square just comes along. Okay, so this thing in the third box is the third and final Pythagorean identity. For now, just have these in your notes. Do your best to memorize this first one because it's going to get used a lot. And we will be cycling back to these three as we develop the unit circle model that's coming up in a future unit. But for now, it's just really for exposure, okay? Thank you so much. This is the 4th lesson of Trig Unit 1. Of course, go back and listen to any part that you felt a little bit wobbly about, and I will see you in class.